increment this pointer. So we need another process. So is on the positive edge of the clock, begin and end. The pointer will be incremented positive edge. We put this non-blocking assignments +1. So each time the pointer increments, we will put the data, if it is valid, of course, in our temporary RAM. This is the writing process. Now we need to, when we have stored all the data one by one, because we are streaming pixel by pixel, we need to, when you finish all the size of this RAM, we need to read it out. What are we going to do? This another process which is will be run parallel to this process and this process. Always positive edge, same clock, begin, and same thing. Be using to read from the memory in the same way, read +1. Of course, we need it in the beginning also as register of the same size. Okay, this is the first step. But we need to tell it when to read this variable. We use it if this variable is on. We do increment this pointer. We assign at last out data our RAM in which we have already stored the data pixel by pixel. But this time we need to use the. Of course, we need to use this to initialize our data for the writing and the reading. So if I reset is on, we initialize the pointer equals or we receive 0. Else we start the counter. Same thing with the reading process. So if okay, yeah, it's on. If now in this case we don't need, whenever we have the valid data, we just read it. Here we forgot this, and here also we need to do the same thing. That is on, we initialize the pointer. Else check if the data is in reading mode and reads. Now we need to test it and check if we have not made any mistakes. We go to the run simulation, behavioral simulation. So now we get this window. I'll explain how it works. we remove this. First, we need to right click on the clock, force clock, 1 for that edge, 0, and we keep 100 nanoseconds for a period. Also, first we need to initialize, right click, force constant, 1, first value for the input data, right click, will start by 0, hexadecimal, the data valid also 0, and the reading data is 0 because we need first to write to the RAM, then read. Okay, so I will explain. We have the input clock, reset, the data coming in byte by byte to our RAM. Then we need to check if the data coming from, for example, from camera or something like that is valid. If it is valid, we get our output. Of course, inside the memory, it will be using this buffer, 256 bytes size, and using these two pointers. We start by running 1 or 2, wait for it, then we zoom out to see it because the period is too much. We see that we'll have 1 period, 2 period, and the result is 1, data is 0, data valid is 0, and reading data is 0, and the counters are 0. And this buffer is still not filled. Now, if we try to run it, remove the reset, it means we force this to 0, put the first data value, for example, 1, and also we need to put it as valid, otherwise it wouldn't be taken as a value inside our memory. We try, we see that this turned 1 and this one. We continue, we keep this as valid. Okay, I made 2 periods, that's why we have this. We continue, new value, 3, keep the data valid as 1, 3, continue, 4, until we reach 256 bytes. Now we check if we can read. We put a data to 1, we remove data valid just to say that we are going to read now, so we don't need to write in the same time. Same thing, we'll notice that this has become 1, and we are starting having data. We need to check these pointers. We see that when we were writing, the pointer were incremented until the point where we started reading. This has become 1, following period or positive edge, giving us the pointer increasing. The problem now is we are not getting the O data. We need to debug our code. We come back to the code and check why this O data is not giving us the data that we have stored inside our temporary buffer, termed RAM. It was alright. We check the code, it is okay. First, we need to check if the data input data is valid. When it is 1, put this data in buffer. Same time, we need to implement this in independent or parallel process. When we finish this, we read. So we give this input to activate our RAM, reading this combinational instruction. The data will come out one by one. We come back to our simulation and we check that first value 1. We detect a mistake. It is not giving the value we have put in, which is from 1 to 4, which giving us just 1 and 0. We come back to debug it. We check in the write-in mode. You see that checking the data is valid to put it in the buffer, but not the incrementation. So we need to do the same thing to avoid this problem. We run simulation again, save, and we'll see. Now this one we redo the same thing. The clock, what is that? 1. Initial value as 0. Valid data for the beginning as 0. Reading data also as 0 because we are not reading. We run 2 periods or 3. So we have our data which is initialized. Now we start putting in data. Move reset. First value 0. Sorry, first value is 1 because we are starting, but it has to be valid. Run 1. So we have put 1 in our temporary run. We have 256 position. We'll check that. Increase 1. We'll see that first one has become 1. Okay. So we don't have to forget the pointers. Just display it in decimal because it's just a counter. Second value 2. You see. Third value 3. Fourth value 5th value until the last one. This is how it's working in reality, pixel by pixel filling in the temporary RAM. Now we don't need to continue until 256. We'll start reading. Put this one and data. It depends, we can leave it valid if the data is still coming. So we'll see if we'll have this output data. We'll see that we have has become 1 for the reading. Continue. So first value is 0. Second value is 1.